In this lesson, we're going to learn about the graphs of tangent and cotangent. Just like the other trigonometric functions, the graphs of tangent and cotangent are also periodic in nature. They also have a series of vertical asymptotes, but still look different from the other trig functions. For instance, the graph of y equals tangent x looks like this. So with secant and cosecant, you had the u-shapes. With sine and cosine, you had the waves. And with tangent, you get shapes like this. Cotangent, however, is very similar. In fact, it almost looks like just the reverse of tangent. If you notice a couple of differences, one, there is differences in the location of asymptotes. But also tangent is always increasing, whereas cotangent is always decreasing. So just so you have that handy, the key difference is tangent is increasing, cotangent is decreasing, and the graph of tangent is undefined, meaning it has the asymptotes at non-zero multiples of pi over 2, whereas the graph of cotangent is undefined at multiples of pi. Now, we'll explore where these shapes come from in just a minute. Right now, let's take a look at different things like domain and range. So for tangent, the domain, we're undefined at non-zero multiples of pi over 2. So in order to express the domain, we do need to use builder notation and write it as x such that x does not equal 2n plus 1 times pi over 2. And so that ensures that we have odd multiples of pi over 2. N is of course assumed to be an integer here. That expresses our domain. The range, if you look at the graph of tangent again, if you squashed the graph of tangent up against the y-axis, you would have some point on the entire y-axis, which means that the range is actually negative infinity to positive infinity. The period, let's look at the period. So we know the period is how long it takes for the cycle to repeat itself. So let's start with this arrow here and see when we end up back at another arrow like that. Well, here we are. So this went from essentially negative pi over 2 to positive pi over 2, which is a length of pi. So the period of tangent is only pi. Now for cotangent, the domain, we have to make sure we exclude all points that are multiples of pi, and that's a little easier to express. So we just need to say the domain is all values x such that x does not equal a multiple of pi, where n is an integer. It could be negative, positive, or 0, and that's fine. The range for cotangent is also negative infinity to positive infinity. And the period, if we start with this arrow and kind of work our way to the next similar point, well, here we are, and this is a distance of pi. So the period of cotangent is also pi. So when you are looking for changes to the graphs of tangent and cotangent, you're going to take the original period divided by that multiplier we've been calling b. So instead of doing 2 pi over b, as in the other trig functions, we would find the period changes by doing pi divided by b. So we take the original period divided by that constant. And so it probably is a good time to first explore where the graphs get their shapes from. I have a couple of applets to help us see that. And then also explore the basic transformations that are affecting the graphs. So I have the same setup as I had with the other trig functions. I have a unit circle on my left with a point P on that unit circle, and I'm just taking the y value and the x value of P and dividing those numbers, and that's where the point that's plotted comes from. As I move P around the unit circle, well, as I move P around the unit circle, you'll notice that the function is increasing, and it actually is increasing very rapidly until we get to the point where we're at 90 degrees. But at 90 degrees, the coordinates of point P would be 0 on the x, 1 on the y. So when we evaluate the tangent, y divided by x is 1 divided by 0, which is infinity. So that's where we're getting our first vertical asymptote. If we continue rotating around the circle, you'll notice now we have negative values again. And we continue rotating up until this point right here at pi. And technically this is, if you start the cycle from 0, this is the full cycle of tangent, because we're back to where we started from. And then if you continue rotating around again, it simply redraws the same mapping. So by 2 pi, we're actually getting 2 full cycles of tangent. Now if I show you the graph, the original graph, you'll notice that everything lines up as it should. So asymptotes at odd multiples of pi over 2, and this function is always increasing. Cotangent is a similar situation. If you take the point P and rotate it around your circle here, so I'll just drag that point. The only thing that changes is this is now a decreasing function. So as I get new points, the values of y are going downward instead of upward. So it's a decreasing function. But again, you get 2 full cycles of this by the time you get to 2 pi. So the period of cotangent is just pi. And the graph here matches up with what we expect. Let's look at some transformations of the graph of tangent. Now, we have the same sort of transformations that we did with the other trig functions. C is a vertical shift, A is an amplitude change, B is a phase shift, a period change, and D is a phase shift. Now, if I change any of these, let's start with the simple ones. So beginning with the vertical shift. So if I have a change in vertical shift, then all it's going to do is move the graph up or down. It's a little difficult to see because it's just moving these points that would have been crossing the x-axis up or down effectively. The phase shift is relatively easy to work with. It's just moving me to the right or left, however many particular units. But it is such a small period in general that it doesn't take a lot of change to get right back to the exact same shape. The period change, if I change the period, then that's just changing how long it takes to complete a full cycle. So if I change the period to 2, so I have a multiplier of 2 on my tangent, it's going to complete the cycle in half the time. So starting from 0, if you go up to pi over 2 instead of pi, the cycle is completed. And if you change your amplitude, it's really just how stretched out that curve is in the middle that really gets affected. Now, when it comes to drawing these, it's actually very difficult to express accurately changes in amplitude or changes in vertical shift. A lot of times your problems that you're working only involve period changes and phase shift, because those are the most visible ones with tangent and cotangent as well. So let's look at the graph of cotangent, and you'll notice things are basically the same as with tangent. It's just decreasing instead of increasing, and the location of asymptotes is different. Although I didn't draw in the asymptotes simply because it is difficult to kind of draw these lines in programmatically, because you have to calculate the number of lines, the position based off of phase shifts, period changes, and whatnot. It's just much easier to just kind of allow you to visually put them in, or if you want to draw them in yourself, just draw them in. That's fine. So the changes here, again, amplitude is kind of, you can see it when you have the computer doing it, but if you were to draw this, it's really difficult to express. So generally we don't work with amplitude changes. The same is true about vertical shifts. They're kind of hard to draw. We really only look at changes of period, because that's easy to work with. So for instance, if you have a multiplier of 2, that means you're going to finish your entire cycle by pi over 2 instead of pi. And that would be simple enough to draw in. Similarly, any phase shift is relatively easy to express. You just move your graph to the left or to the right, respectively. So let's take a look at drawing some graphs, starting with a cotangent graph. So the different changes that we are normally working with, changes in amplitude, period, phase shift, and vertical shift. There's no vertical shift in this case. There's no phase shift in this case. Amplitude, we generally don't see that as even a change with tangent and cotangent, so you generally don't have to worry about it. You don't want to say that there's no amplitude. Maybe you want to say there's no change, or the amplitude's 1, whatever. The period, however, is affected. The period here normally is pi, but I have a multiplier on my x, so I need to divide by that multiplier. So my period is pi over 2. So I'm going to complete this entire cycle by pi over 2. Now, what I do is just kind of remember cotangent. It is a decreasing function, and it is undefined at multiples of pi. So I just remember those two pieces of tangent and cotangent. Tangent is increasing, cotangent is decreasing. Cotangent's undefined at multiples of pi, tangents non-zero multiples of pi over 2. Now, so the graph is going to be undefined at 0. So I'm going to have a vertical asymptote at 0. Now, if the period change weren't happening, my next asymptote would be at pi. But the thing is, my cycle is now going to complete by pi over 2, which means my next asymptote is going to be at pi over 2. And then I'm going to have other asymptotes, just multiples of pi over 2, because the period is pi over 2. Now, the point that's halfway in between those asymptotes is the point where I'm going to be crossing my x-axis. So at these points along here. The only thing that I want to keep in mind is that this is a decreasing graph. So because it's decreasing, I would start up here and go to the asymptote this way. Start up here, go to the asymptote this way. So that's how I kind of get this shape. And you can fill in one period. You could fill in the entire graph. It doesn't really make a whole lot of difference. Once you get one, you can effectively get the others anyway. That's all there is to that. Next, let's graph y equals the tangent of x plus pi over 4. So the thing that's happening here, again, amplitude. You're not really going to see an amplitude change with tangent and cotangent, so it's just one or no change. It doesn't really matter. Period changes. Generally, you might see a period change, but in this case, there's nothing multiplying my x. So there is no period change, which means the period still completes in pi units. A vertical shift is not occurring here, so there's none. There is a phase shift, however. The phase shift is my shift to the left or right, and in this case, the graph here is going from to 5 pi over 4, but I'm going to be shifting to the left because it's a plus 5 pi over 4. You go in the opposite direction of that sign. Okay, so that's the only change that I have to worry about. How do I make that happen? Now, tangent is going to have vertical asymptotes at non-zero multiples of pi over 2. So let's start with this asymptote that would have originally been on the graph. So it has to move 5 pi over 4 units to the left. In order to move that 5 pi over 4 units to the left, one thing I could do is just say, all right, well, pi over 2, if I want to move it 5 pi over 4 to the left, what do I get if I subtract that? So this would be 2 pi over 4 minus 5 pi over 4, which is negative 3 pi over 4. So that means this asymptote is going to map to negative 3 pi over 4. But where is that on my scale? Let's take a look here. So this tick mark here, which is halfway between negative pi over 2 and 0, would be negative pi over 4. This tick mark here, which is halfway between negative pi and negative pi over 2, would be negative 3 pi over 4. So that's where that asymptote would map to. So there's that. Now, let me get rid of this asymptote because it's not actually part of the graph that I'm drawing. I'll go ahead and fill in, like this would be the point pi over 4. This would be the point 3 pi over 4. And I don't know if I need it or not, but this would be 5 pi over 4. Now, I know where that asymptote is, and I know that the period of tangent is pi. So that means pi units to the left and to the right of this asymptote are going to be the next asymptotes. So if I go from negative 3 pi over 4 plus pi, got to work with common denominators here. That means my next asymptote is at pi over 4. Or 1, 2, 3, 4 units away. So 1, 2, 3, 4. My next one would be 5 pi over 4. So I've got a handle on where my asymptotes are. And the symmetry of this graph tells me that at this particular point here and this particular point here, the graph is going to cross the x-axis. It's always going to be halfway between your asymptotes. But how do I fill in the rest of the graph? The thing that you have to remember is that tangent is an increasing function. And since it's an increasing function, you need to start at the negative, pass through, let me get that a little bit closer to the correct shape. So negative pi over 4. So come up and pass through this point up to the next asymptote. Similar on this interval here. Just draw them in as increasing curves as best you can. That's all we're looking for.